Good day, everyone. I am Ma'am Kristin Lu, and welcome to the science class. The topic that we are going to discuss today is all about mass. So for us to be guided with our lesson for today, let's have our learning objectives. So at the end of the lesson, we should be able to analyze the relationship between atomic mass, molecular mass, and molar mass, and explain how they are applied in scientific calculations. Demonstrate guided calculations to determine molecular and molar masses, and articulate the significance of accurate mass measurements in scientific experiments and their applications in real-world scenarios. Have you tried following a recipe of your favorite food but end up not making it quite right because you didn't bother to weigh or measure the ingredients? Well, every day we perform a variety of tasks that require the ability to count or measure. Let's take a look at these pictures and observe what is happening in each photo. What does this picture illustrate? Well, it looks like someone is washing the rice grains so that he or she can cook it. But in order to cook the rice, what should we do first? For us to cook the rice, we should wash it first, then put the right amount of water. Think about cooking rice with the right amount of water. What happens if there's too much or too little water? If there's too much water, the rice becomes mushy, sticky, and overcooked. Too little water will make the rice remains undercooked, hard, or burnt at the bottom. Well, a simple task of cooking rice requires the exact amount of water, right? Alright, let's proceed to this next picture. How do construction workers ensure the right ratio of water, gravel, and cement to make sturdy concrete? By combining the exact amount of cement, sand, gravel, and water to make a concrete. Construction workers know the exact combination of these materials that will come up with the right consistency of concrete. So from the pictures and examples that I presented, what do these examples have in common? When doing a task, we need the right number of materials or ingredients. Then why do you think precise measurements are important in these scenarios? It is important to measure the ingredients properly so that we don't make mistakes. So just as these measurements are important to us, so too are the amounts of substances essential to a chemist in the laboratory. In your own understanding, what is matter? Matter is anything that occupies space and mass, right? Well, that's right. Matter is made up of ultra tiny particles called atoms and molecules. Counting these tiny particles in a drop of water alone would involve thousands of trillions of molecules of water. By measuring mass, let us define what is mass. Mass is the measure of the amount of matter in a body. We can measure the amount of matter in a certain element, compounds, material, or in a body through mass. Then, how about weight? Weight is the measure of the force of gravity acting on a body. So now that you know the differences of weight and mass, let's go back to the devised way or measurements in chemistry. What are those measurements? They are the atomic mass, molecular mass, and molar mass. Then what is an atomic mass? Atomic mass is the mass of an atom or a molecule. The mass of an atom in atomic units is approximately equal to the number of protons and neutrons. One of the main measurements used to describe substances in chemistry is atomic mass. Atoms of different elements have different masses. The actual mass of an atom is so small that a special unit is used to describe the mass of an atom. How do chemists measure the mass of an individual atom? Through atomic mass units. So chemists measure the mass of an individual atom not in grams but in atomic mass units or AMU. Atomic mass unit can be loosely defined as the mass of either a proton or a neutron. Therefore, the mass of an atom in atomic mass unit is approximately equal to the number of protons and neutrons, which is also its mass number. Here in our example, the atomic mass of hydrogen can be found next to the chemical symbol on the periodic table. It is 1 atomic mass unit. Right, let's have this example. Using a periodic table, find the atomic masses of the following elements: A. Sodium, B. Lithium, C. Helium. Try to answer it on a scratch paper. Okay, so what is the atomic mass of sodium? 22.99 atomic mass units. How about lithium? It is 6.941 AMU. How about helium? It is 4.003 atomic mass units or 4 atomic mass units. Very good! Now that you know about atomic masses, let's proceed to the molecular mass. Molecular mass is the mass of one molecule. It is the term generally used for compounds formed out of covalent bonding. In the previous lesson, we learned that formulas of compounds are written with subscripts that represent the number of atoms in that formula. If molecular mass is the term for compounds formed out of covalent bonding, then formula mass is what we used to call for compounds formed from ionic bonding. Before we proceed to the examples on how to find molecular or formula mass, we have to remember these reminders. For our purpose to avoid confusion, we will simply use molecular mass for all kinds of compounds, whether ionic or covalent. So, for molecular mass, we must be conscious of the following. The atomic mass is provided by the periodic table. Remember, atomic masses are not meant to be memorized. Be aware of the subscripts, especially when there are parentheses. The subscript outside the parentheses must be multiplied to the number inside the parentheses. We must be aware of the subscripts if we have to multiply or not. Alright, let's have this example. There are 2 hydrogen atoms and 1 oxygen atom in a molecule of water. The calculation will be 2 times 1.008 atomic mass units plus 1 times 16 atomic mass units is equals to 18.016 AMU or atomic mass units. Do you get it? Okay, try to answer this example. There is one atom of magnesium, 2 oxygen atoms, and 2 hydrogen atoms in a molecule of magnesium hydroxide. What is the answer? Correct answer is, the calculation will be 1 times 24 AMU plus 2 times 16 AMU plus 2 times 1 AMU is equals to 38 atomic mass units. Good. So now that you understand how to find the molecular mass or formula mass, let's proceed to the molar mass. What is molar mass? Molar mass is the mass in grams of 1 mole of a substance. The SI unit is grams per mole or G/mole. In grams of 1 mole of a substance is called the molar mass of the substance. It depends upon the masses of the unit particle, whether it is an atom, as in the case of an element, or a molecule in a compound. The molar mass of a substance is determined from its atomic mass or formula mass. Molar mass is numerically equal to the atomic mass or molecular mass. 1 mole of a compound also contains Avogadro's number, but as molecules and not as atoms. For example, 1 mole of water with a molar mass of 18 grams has 6.02 times 10 raised to the power of 23 molecules of water. Observe this table. From this table, how did we get the 12 grams per mole? So we get 12 grams per mole from our atomic mass. Then we will have the answer as 12 grams per mole. That's right. So how about this next example? What is your answer? So the correct answer is 6 times 12.011 atomic mass units plus 6 times 1.008 atomic mass units plus 1 times 15.999 or 16 AMU is equals to 94.113 atomic mass units, and the molar mass is 94.113 grams per mole. Good job! So you can also try to solve this one and check your answers. And that's all for our class. Goodbye!